Good morning, geometry. Once again, we got another class to deal with today. We get to look at the last section of chapter 18 that deals with volume. Again, I'm hoping you guys found this to be relatively easy. So let's look at the very last section today. So we're going to look at section 18-4, where we're going to be looking at finding the volume of spheres, and also we're going to include in that composite figures that may have spheres, cylinders, pyramids, cones in it. Okay, so we'll get right into it. It's another easy section. We're going to use our calculator today, just help you guys out in doing shortcuts. The first thing we'll do is, again, the explore part is just going into details on how to find the formula. Once again, it is important, but I'm not going to spend time teaching on it. And the volume of a sphere is, again, those of you who don't know what a sphere is, it's just like a ball. Soccer ball, basketball, baseball, golf ball, just a regular spherical shape is a ball. So here we're going to go. Here's the volume. The volume in this case is 4/3 times par times pi times the cube of the sphere's radius. All right, so what I'm going to do is show a few examples, let you guys stop the video and you can copy the work down, see what's done. I'm not going to go over everything in here. So again, example 1, again, would have been a problem that you guys would have done to get you into the book. Again, here are the answers. I'll let you stop your video, highlight certain issues, do the work, and check your answer. But then there will be some problems I'll work out, and the problems I'm going to work out, I'm going to show you how you would do it, calculating your answers using your calculator. So here's our first one. We have a spherical water tank that has a diameter of 27 meters, and they want us to find out how much water can the tank hold to the nearest liter. So what we're doing is, in this problem, we are converting a volume of, in this case, of cubic meters into how many liters are in it. And they give us a hint. They're telling us that 1,000 liters is equivalent to 1 cubic meter. Now, the class we're dealing with right now, a lot of these are very, very simple. Again, some problems we'll have to do a little bit more work on the conversion factors, but we'll worry about that in another time frame. All right, so once again, we're using the volume formula of 4/3 times pi. Once again, I'm not going to use 3.14. We're going to use the pi on the calculator, times the cube of the sphere's radius. So first things first, they gave us all our information. And again, setting it up, I always write my formula down and then I apply my given information into my formula. And you're probably asking me, where did I get that 13.5? Well, the problem gave us our diameter. Now again, your diameter, once again, is your radius is half of your diameter. So if I go 27 divided by 2, then we get our radius, which is 13.5. Now I'm going to show you how to do this using your calculator so that there is no errors. Okay, it's relatively easy. Here's how I do it. Okay, first thing I do is I put a parentheses, then I go 4 times our pi times the 13.5. Now it's going to be to the third power on the 13.5. So that's the button up here we have to use. Caret 3. Move your cursor outside, parentheses, and then we're going to divide it by 3. Now again, you could have done it another way. It's going to be the same thing. So here we have 10,305.97. And what I'm going to do is I'm just going to go and put that to the nearest cubic meter. So that is 10,305. In this case, we have to use our units of a cubic meter. Now the next question is, how do you find the capacity of this tank to the nearest liter? Well, we've already been told in the directions under the hint that we know that 1,000 liters is equivalent to 1 cubic meter. So we have 13,305 cubic meters. That's our volume. So if we multiply that times 1,000, we get this number right here, 10,305,000. In this case, it's 10,305,000 liters. That's what I said. So, like I said, this is another easy section. Again, it all ties into your formulas. All right, so next thing we want to do is finding volume when we're dealing with a composite figure. Once again, composite means we, like this example right here, find the volume of this composite figure, and they want us to round to the nearest cubic centimeter. So if you look at the shape, it is made up of two geometric shapes. We have a cone and we have a hemisphere. Okay. Now again, what I do is I know we're going to have to deal with volume. So again, I know I'm dealing with a cone. So again, I know the formula for a cone, goes back to a previous section, is 1/3 pi r squared h. And then we also know that the volume of a sphere is 4/3 pi r cubed. But the problem saying is we're dealing with a hemisphere. Now, hemisphere is half of a sphere. So again, you're probably noticing this formula right here. That is half of that. Okay, you can do your algebra or your multiplication of a fraction. In this case, you're going to see why it's 2/3. So again, I'm going to let you guys copy that. Like I said, this is not a hard section. You guys are probably so happy now that you're dealing with something easy. All right, let's do one more, and then we get to call it quits. So at the bottom of the page, there is the your turn number 6. What I'd like you to do is pause your video, and go back and try to work it out, and pull out your solutions sheet and see what answer they have and compare it to yours. All right, pause it, do the work, and come on back. All right, you're back. So we have a composite figure of a cylinder. We have a cylinder here. And we have a hemispheric hole in the top. So in other words, part of this cylinder has been hollowed out by a hemisphere. The bottom of the hemisphere is tangent to the base of the cylinder. So in other words, it goes all the way down and it touches the bottom of the cylinder. We want to find the volume of the figure to the nearest tenth. Now, when they talk about this, they're talking basically, the volume of the figure is taking the volume of the cylinder and subtracting from that the volume of the hemisphere. All right, now, I've been doing this since my college days. I set everything up first. So the volume of a cylinder, once again, is pi r squared h. That goes back to a previous section. Pi radius squared h. Again, the radius in this case is indicated by a diameter of 7. So that means the radius is half of 7, which is 3.5 inches. Okay, minus the volume of the hemisphere, which in this case is half of a hemisphere. So it's 2/3 pi r cubed. And there's your setup. And all we got to do now is just do all our gazindas. This goes into that. All right, so I know that we have, I'm going to do this in the calculator in one shot, parentheses, pi times 3.5 squared times 3.5. That takes care of the volume of the cylinder minus parentheses. And again, I'm going to do the 2/3 as a 2 divided by 3. Okay. Previous part of this video, I just did it a little bit differently. You're more than welcome to. But again, in order for us to do this, we got to put that 2/3 in a parentheses. So parentheses, 2 divided by 3, parentheses, times pi times 3.5 raised to the 3rd power, or cubed, parentheses, Okay, that's setting up with the calculator. And all we got to do now is just hit enter. And if we hit enter, boom, we get 44.89. So I'm going to round it to the nearest tenth. So the volume of that composite figure will be 44.9 cubic inches. So that is what section 18-3 is all about. Nothing more than taking and finding a volume of a sphere, and also dealing with composite figures that also include or deal with spheres. All right, guys, that's it on chapter 18. We'll have a test next, and then we go to chapter, I don't know what the next chapter is. I think I skipped one. I don't know if it's 19. I think it's dealing with surface area. All right, nice talking to you. Catch you later.